Hello, in this video we are talking about section 5.2, which is ASA Triangle Congruence. So the three things that we are going to look at is, first we want to know what the ASA Triangle Congruence theorem is. Then we're going to apply that theorem, and then we're going to use that theorem while we are writing proofs. So, first let's just talk about what is ASA Triangle Congruence theorem. Well, first, this ASA, what it stands for is angle, side, angle. And basically, it's a shortcut to prove that two triangles are congruent. So for instance, if we don't have all of the side lengths labeled and all of the angle measures labeled, as long as we know one angle, the side in the middle, and another angle, we can say that these two triangles are congruent. Okay? So we want two angles and the included side. So that means I want two angles and the included side. So it has to be the side in the middle. And as long as those two angles and the included side are congruent to the other triangle, then these two triangles are congruent, even though the other parts of the triangles are not labeled. Okay, so it's like a little shortcut. So let's look at example number 1. We're trying to find two angles and an included side that are congruent. Okay, so let's look at what we do have. We have a 2.3 being congruent to a 2.3. We have a 61 being congruent to a 61. The last thing we would need for angle, side, angle is to have this 45 be congruent to this angle. But that angle is not labeled, so we're going to have to do a little bit of work. Remember that the three angles of a triangle have to add up to 180. So if we work backwards and go 180 minus 74 minus 61, we can figure out what this third angle is. So type that all on my calculator. I got 45. So angle D is 45 degrees, and that is congruent with the other angle in the other triangle. So because we have two angles, the 45 and the 45, the 61 and the 61, and the side length in between them, we can say that these two triangles are congruent because of the ASA theorem. Let's look at example number 2. Very similar here. Let's see what we have matching. Well, we have an angle, the 31 degrees. We have a side length, 62 inches. To be able to use ASA, or angle, side, angle, I would also need this 110 to match up with this angle P. But again, we'll have to work backwards. So I'm going to do 180 minus the other two angles in the triangle. So minus 38 minus 31. That makes 111. So here, when I look at my two angles and the included side, my 110 and my 111 don't match up. So these two triangles are not congruent. For our last example, we have a proof. So we first need to look over to the side at our given information so that we know what we are starting with, figure out what we're trying to prove, and of course use the diagram to help us. So first, let's start by putting our given information into our table. So we are given that angle MQP is congruent to angle NPQ. That is a given fact. We are also given that angle MPQ is congruent to angle NQP. So let's label that information in our diagram. We have this angle is congruent to this angle, and we have this angle congruent to that angle. And what we want to prove is we want to prove that the two triangles of this diagram are congruent. What you are trying to prove, this line, always goes at the bottom of your two-column proof. Now we have just one step left to figure out. Well, this whole section is about ASA, angle side angle theorem. And if we look at our diagram, right, currently we have two pairs of angles that are congruent. And to be able to use angle side angle, we would also need to know what this inside side length is and make sure that it's congruent. Well, see how in the picture, right, this line QP is a part of both triangles. It's a part of MQP and it's a part of NPQ. So what we can do is we can write a reflexive statement. Is what it's called. Okay, QP is obviously congruent to itself, right? Everything is congruent to itself. That's called the reflexive property. And now that we have two pairs of angles and the included side all congruent, we can say, yep, the two triangles are congruent, and our reason is the angle side angle theorem.